Welcome to the next session of heat transfer. In the last class, we have discussed about the amount of heat that is transferred because of thermal conduction. In that, we came across a term, thermal conductivity or K, which is basically the property of a medium. It defines its ability to conduct heat. Today, we will be discussing some more detail on this thermal conductivity. Thermal conductivity of a material is basically a measure of how fast the heat may flow in that material. A large value for thermal conductivity indicates that material is a good conductor of heat. A low value indicates that it is a poor conductor, or we may say it is basically an insulator. For example, the value for copper is about 450 watt per meter Kelvin. And we know that copper is a good conductor of heat. On the other hand, the value of thermal conductivity for water is about 0.6 watt per meter Kelvin. So it is basically a poor conductor of heat. So depending upon the value, we can judge whether the given material is a good heat conductor or a poor heat conductor. The thermal conductivity of a solid may be more than 4 orders of magnitude larger than that of a gas. This is basically due to difference in intermolecular spacing for the two states. In solid state, the conductivity is mainly because of either free electron movement in case of metal or because of lattice vibration as in case of non-metallic solid. But in case of fluids, that is liquid or gases, the conductivity is majorly due to molecular collision. That is, a molecule from high temperature region will travel and collide with upcoming molecule, and during this collision, it will impart its energy. So in liquid, the molecular distances are less as compared to gases. So the liquid will have higher conductivity as compared to gases, and gases will be having the lowest thermal conductivity. And in other hand, the conductivity of solid will be higher than both of these. And in solid, it will be in sequence like pure metal, then alloys, then non-metallic solid, and then some insulation system. Pure metal, the majorly thermal conductivity will be because of free electron movement. And as we all know, that pure metal are having a large number of free electrons. So conductivity will be high. In case of metallic alloys also, the thermal conductivity will be because of both free electron movement and lattice vibration. It will depend which percentage of element is higher, but the conductivity of an alloy will always be less than the pure metals from which it is made. Then in case of non-metallic solid, as we know, there are no free electrons available. So the main cause of thermal conductivity there is lattice vibration. That is vibration of its molecular structure or lattice structure. Variation of thermal conductivity. The thermal conductivity can vary majorly because of temperature. If we increase the temperature, then the molecular collision will take place at a faster rate, since the root mean square velocity, that is VRMS, is directly proportional to absolute temperature in case of gas. So since we are increasing the temperature, this velocity will be increasing, the collision will be at the faster rate, and the conductivity will increase for gases. But in case of liquid, it will be opposite. as the density of liquid will be decreasing because of thermal expansion. And since density is decreasing and molecular collision is increasing, the overall effect will be that conductivity of liquid will be decreasing with increasing temperature. In case of non-metallic solid, the main reason for conductivity is lattice vibration. If we increase the temperature, these vibration increases and hence the conductivity of non-metallic solid will always increase. And in case of metal, when we increase the temperature, the conductivity will be decreasing as the increase in temperature will increase our resistivity, that is the resistance to the movement of free electron. And hence, in case of metal, the conductivity will be decreasing. Exception being aluminium, uranium, and mercury. The value of thermal conductivity also depends upon the grain structure. So, the thermal conductivity can be same in a medium in all the direction, or it may be different in different direction. If it is different in different direction, the material is known as anisotropic, and when it is constant in all direction, the material is isotropic. The variation of thermal conductivity with temperature can be shown by the equation K equal to K naught 1 plus alpha T, where alpha is a constant. Here we can see thermal conductivity of different materials. Metals that have high thermal conductivity like copper, it is having of 390 watt per meter Kelvin, aluminum 240, brass 110 watt per meter Kelvin. However, insulators like glass, water, wood, air, these materials have the conductivity of lower value. If we see, air is also there in the list. That is, air is a good insulator. But if we are talking about convection heat flow, in convection heat flow, the large airflow will help in enhancing the heat transfer. So it will also be dependent upon the conditions where we are using these values. Another thing that we can see from this table is the material which is having higher thermal conductivity are those material which are having higher electrical conductivity. So we can say the materials which are good conductor of electricity are also the good conductor of heat. So this was all about thermal conductivity. In the next session, we will be discussing about the amount of heat transfer by convection and thermal radiation.